Today we're going to be perfecting our process for making these carabiners. The first run just finished and it took 19 minutes and 7 seconds. In production, that means I'd be getting 2 carabiners every 19 minutes, so a carabiner takes about 10 minutes. I want to get that time down as much as possible. But before I make any code tweaks, I want to machine the other side of this part. The carabiner came out super warped. There's a very noticeable curve on the backside of the carabiner, and the wall thicknesses are nowhere near equal on the op2 side. Now, interestingly, they are equal on the op1 side. That implies to me that this warping happened in op2. The warping also changes the geometry of the lockup, and the carabiner just doesn't work anymore. I don't really have a good idea on how to fix this. My only theory right now is that I clamped it too tight with the clamp and it distorted the part. I'm gonna run the exact same thing again, except I'm going to very lightly clamp it in this time. It is the next day, and I have an idea, at least, that we can try. When I was first prototyping these, I used to cut the slot for the flexure all the way through in op1. Last night, I was only going halfway through on op1 and op2 and meeting in the middle. I'm gonna go back to my old method and see if that changes anything. We have a problem. The carabiner is no longer where it should be. The tool's still in one piece. I guess that's good. So this is what I think happened. End mills, when they're cutting, they apply both a lateral force, but also they pull upwards on the part. The end of the arm is not really supported in my fixture. I think it started bouncing around, and eventually it caught the end mill, which pulled it up and broke everything. So I played around in CAD for a couple hours, and I could not find a way to get another Mighty Bite clamp to support the arm of the carabiner. But I was talking to some friends on Discord, and we realized we could fit an M4 screw in this little gap. I put together some code that will go ahead and drill and tap that hole, but then also cut a little pocket that we can use to pry out the carabiner. It is now the next day. I had to walk away after breaking the tap in that part. I was a little bit frustrated, but it's a new day and I think I can tackle it today. So the biggest thing I have going for me right now is the reason that I broke this tap, and it's that I used a super cheap one. I don't know why I would ever put that in my machine instead of doing it by hand, and I regret that decision. But because it's a cheap high-speed steel one, that means we can just use an end mill and drill it out, I hope. I've never actually done this, but YouTube said it was a good idea. I cannot believe that worked that well. I think we need to go deeper. I had to stop it before it finished because I didn't have enough clearance for the collar nut before it hit the top of the fixture. Now I just need to hand tap all the holes. I broke a second tap in the exact same hole. Well, that wasn't a particularly productive work session. I think I'm gonna go do some dishes as I figure out what to do now. I think I know what I'm gonna do now. To fix this, I'm going to drill all of those holes oversized and then put an insert in the top of them. I can machine that insert separately so that if I break anything, it's not part of the final fixture. And if my threads get stripped out, I can always just replace the insert. Also, instead of using a tap, I'm going to thread mill because I'm really tired of breaking taps. But first, we gotta remove that broken tap again. Fortunately, I already have the code and tool loaded. I'll be making those threaded inserts out of this brass rod for no other reason than this is what I have lying around. Well, modifying the fixture went pretty well, but I got a case of the blue screens when I went to go make the insert. It's really hot in here and I can feel that the controller itself is really hot. So I'm just gonna call it a day and hope that it's just the heat. and we'll see how it goes tomorrow. I have lost count of how many days this project has taken, but it's been so many days that I am out of orange shirts and I'm in off-brand colors. First things first, let's power it on and see what it does. So it started right up. I guess it was just heat. I'll just have to make sure I keep a fan on there or something when it gets to be 90 degrees in here again. To get those inserts to fit just right in the fixture, they need to be 0.450 inches. Right now they are 0.453 inches, which is pretty close but not quite there. When I first cammed these, I intentionally left 2 thou extra, 1 thou on either side of the part, so that I could come back and clean it off later. That last thou is because end mills are made just a little bit undersized, just the way the grinding process works. So I should be able to remove that thou offset and then account for that extra half thou and get parts that are dead on. The next step is to flip these upside down and finish the top of them. In order to hold these while they're upside down, we're gonna make a thing called a soft jaw, which is how you hold weirdly shaped parts. In this case, the soft jaws are designed to hold just one insert at a time, so I need to cut this up into individual pieces. The 4 inserts are done, they look great, and they're on size. I checked the size of the holes on the fixture, and it's a little bit hard to measure with the tools I have on hand, but they seem to be about 1 thou undersized, which makes sense considering we learned my end mill was undersized by about 1 thou. I'm gonna open up those holes just a tiny bit, and then press my inserts in. All of the inserts are now installed. I actually ended up taking them back out and then just adding a little dab of Loctite to make sure they would stay in place. They were just a little bit looser than I was hoping for. The next step is to face them off at the same height as the fixture. I intentionally made them just a little bit proud so that I could come back and do this. That way there is not a gap or a ledge or a crack or anything that could catch chips between the inserts and the part. I also engraved them with some text that says, "Be patient," because I was impatient and used super cheap taps, and that was the cause of my issues. If I had just waited for a nice tap to show up, I wouldn't have had to make these inserts at all. Do you remember that one time when we started this video and it was supposed to be about carabiners? Yeah, this video has gone pretty long. I think I'm gonna have to push that to the next video. If you'd like to support me, you can buy something I make at designtheeverything.com. I also now have a Patreon where you can get a prototype that I'm working on every month. Both of those links are down in the description.